Hi everyone, this is our test 1, number 3, problem number 3 in the test 1. I used Mathematica to actually plot these points, and it uses one of the commands that's not quite introduced in my tutorial video on the YouTube channel, so I made the short introduction in here. So the problem reads that zeta is these complex numbers, and we're going to raise it to the 7th power to show this is going to be 1, and that's what it requires. And we use the De Moivre's theorem to explain this thing is a 7th root of 1 by hand calculation. We need that theorem, but I'm going to actually raise that to nth power in Mathematica and try to plot this point in xy plane. So you can do this in Wolfram Cloud. I'm actually using the full copy in my desktop copy in here so that it runs faster and easier. So first thing, I think I've already explained it, but one thing I'd like to explain: when you use Mathematica and at some point you begin to annoyed by slow performance, is because of the following, and if you're aware of it, and you can improve it quite a lot. So this is going to create, this is a single complex number raised to the nth power, and this capital I here represent the imaginary number, and you have to use capital for built-in function and built-in constant, capital P, and things like that. So if you actually raise this one to the nth power as n vary from 1 to 50 like this, and Mathematica will compute these powers as exact as possible, so it's probably not going to change this one to numerical value. You're going to keep it as symbolically as possible, actually go through the nth power as symbolically as possible. So if you're actually calculating the list of things with 5,000 entries in there instead of 50, and imagine doing this exact calculation with the 5,000 power, is going to take actually significantly longer time. So if you just care about the numerical value of this one, and you're going to change this one to the numerical value by putting capital N in front of it and things like that. That was introduced in my tutorial video. But if it's 50 power, it can handle 50 entries, and it can handle it quickly. So this, if you're doing this, behind the scene is actually calculating things symbolically. So it's a lot more calculation than what MATLAB does and things like that. Alright, here's the second line, and this is the main reason I'm making this video for you guys, is this map function. It's a very, very useful function. This values now is declared as a list of single complex number in here. The shape of the items inside this list, created by this table command, is a single complex number. And what this map is doing is that if you put that list down there, it's going to take out on each item there and do something here in between, calculate this thing. That could be a list, whatever, you put it in there, and it generates another list. Take an item in here in order and calculate this thing and create a new list. It's very, very useful, kind of the one-liner command you can use. There are other ways to do this thing, but this map is very convenient command for that. And this sharp symbol in here is representing the elements from here, and this is another syntax that separates between these two, the list and you're taken out from, and this is what you do with the item in that list. Here's a number, is a real part of a complex number, an imaginary part of the complex number, things like that. So here's a one single complex number. I'm separating to the real part, comma, imaginary part, so you can look at it as x comma y, the points in the xy plane. So that's the format it requires when you apply plot points in xy plane in Mathematica. Alright, so next one is that this point is not a point, it's a list of points. So this additional list of braces around, and they're in x comma y all listed in there, and it's plotting, and this is some option to make this one look nicer. More than that. So you can see we plotted 50 points, but you can see visually that it's actually only showing 7 points because they're overlapping. but this is not a proof, and you know that. It's just a numerical experiment. So next thing I'm going to do is that exactly the same thing. Instead of raising to the nth power, which is a lot more algebraic calculation, use the de Moivre's theorem and do exactly the same thing. Right, here it is, the same thing, except that when I'm raising this thing to the nth power, I'm putting that n inside those complex numbers. Then this is a lot faster calculations probably. And still 50, and it handles pretty much at the same speed. But if this goes up to 500 and 5000, you will notice that this is a lot faster calculation than multiplying n times. So the rest of the part goes exactly the same. So as we expected, it's showing that uniformly distributed 7 points around the unit circle. And so this is a demonstration of how to use this map command. Very, very useful to handle, to do something about lots of a list of things. It's a very useful command.